morning. I'm going to do a Leetcode question today. I used to do tech interviews, and I'm just going to kind of show how I'd like to do one myself if I were interviewing myself. I'm going to start with, let's do easy, and I haven't done it yet, and in the algorithm subset. So let me make sure I got all that, and I'll just pick one. Let's see what we get. All right, so we've got number 2923, find champion 1. Looks to be an easy one, and like it's on the easy list. And let's have a look at what it is. So first, let's start the timer. And what we've got is there are n teams numbered from 0 to n-1 in a tournament. Given a zero-indexed 2D Boolean matrix grid of size n by n for all ij that are between 0 and n-1, where they're not the same, and team I is stronger than team j if the grid value at that index 2D index is 1. Otherwise, j is stronger than I. So team A will be the champion of the tournament if there is no team B that is stronger than team A. Return the team that will be the champion of the tournament. Okay. So an example given is, let's see this 2D matrix. There are two teams. And what is team A? What is team B? Team I. So rows is team I, columns is team j. So here for 0, 1, 0, 0, 0, 1 is equal to 1, which means that team 0 is stronger than team 1. So team 0 will be the champion. Whereas, so could we have invalid ones where the opposite, like 1, 0 is equal to 1 also, and that means they're tied? It doesn't seem to be the case just yet. So that's the first question I'd have. Let's do it in a Google Doc. I know it sucks for me as well, but sometimes interviewers do this in a Google Doc. So let's copy over the question, and I'll keep asking questions about it right now. So let's see. And here we have answer, hopefully. So we're about 2 minutes in, questions being asked. I've asked the first question is, can we have ties? I'm guessing the answer is going to be no, or we have to do a special check for that. But before we get there, let's keep looking at the question. Grid 0, 0, 1, 1, 0, 1, and 0, 0, 0. So there's 3 teams because there's 3 rows and 3 columns. So another question I have is, are we always going to get a valid input? Is it going to be a proper square matrix every time? If not, what does that mean? So here we see that team, there are 3 teams in this tournament. The third team is stronger than the third team is stronger than the first team, the second team, but not the third because it's self. So I'd assume the identity is always going to be 0 for this grid. Here, team 2 is stronger than team 1, but team 3 is stronger than team 1 and 2. Is that right? So let's see. 1 means team 1 stronger than team 0, and 1 means grid 1, 2 means team 1 is stronger than team 2. So team 1 will be the champion. And it doesn't even matter that team 1 is stronger than, oh, they're saying 1 and 3, 0, 0, 2. Well, let's just draw it out. I want to actually visualize this. So 0, 0, 1, 1, 0, 1, 0, 0, 0. So we have team 1. This is for me to understand what's going on, as well as to explain to the interviewer that I understand what's going on. So team 1, team 2, team 3. That's kind of how we have it here. And you know what? We could even build a little table just to show this, but let's not try to be too clever. So right here, we see that team 1 is stronger than team 3. We see that team 2 is stronger than team 1 and team 3. And we see that team 3 is not stronger than anyone. So either team 1 or team 2, team 1 and 2 are both stronger than 3, but team 2 is stronger than 1. So therefore, team 2 is the winner. And that's what they said. Oh. Well, they're doing it 0 indexed. Okay. That means team 1 is stronger than team 0 and team 2. Yes. And team 1 is stronger than team 0. And it doesn't matter that team 0 is stronger than team 2 because team 1 is stronger than both of them. So team 1 will be champion. So let's see. Other questions I might have is always get scarce matrix, and what's the max size for matrix? Can we get empty matrix? And what to return if so? So if it was empty, do we return none? Is a question. So let's assume the interviewer says return none on empty, just arbitrarily. Let's see what the constraints are for size. So it looks like they said that the grid's width and height are always going to be the same. So it answers that question. The size of the grid is never going to be greater than 100, so it'll fit in memory. And we see that the values will always be legal, 0 and 1. And so for all I, so along the identity, the diagonal, it'll always be 0, so it'll be legal. And then for all I, j, where I is not equal to j, it'll always make sure that they don't compete with each other. Like team 1 can't beat team 0, and team 0 can't beat team 1 at the same time. And finally, the input is generated such that team A is stronger than B, and B is stronger than C, A is stronger than C. So we have a transitive property. So I guess I kind of assumed that when I saw this one right here. Well, no, I didn't see that here. So that's a good point. We have the transitive property. So we don't have a direct connection where, like, say 1 is greater than 0 and 2 is greater than 1. We want to say that team 2 is winner because it's better than the other ones. Okay. So that's kind of how I understand the question. Assuming the interviewer agrees with me on this, we're about 6.5 minutes in at this point. I'll start to think about solutions. So what are we trying to do? We're trying to figure out which team is the winner. So we have, I'm just going to start a small skeleton. I'm doing this in Python, find winner, let's just say. And the input's going to be a 2D array, which in this case, we're probably using lists. I can double check with the interviewer if numpy arrays are available, for example. So let's just say the grid is going to be a list of ints. And the output is supposed to be the 0 indexed solution. 0 indexed team winner for team is the winner with transitive, etc. All right, so if not grid, return none. That's the first just base case for empty grid. And eventually we want to return winner. So that's kind of the goal. And now here we have to find the winner. So how do we do that? All right, what are some ideas I have here? First step might be, so one of the ideas that comes to my mind initially is start with a team and see if anyone beats it. And if it does, throw out that team and keep the one that beats it, and kind of do this for all the teams. And if there's any ties at that point, we're assuming there aren't any ties because, well, that's a good question, I guess, is what happens if there's a tie? I had asked that earlier. Let's assume that there is no ties. There's two options that the interviewer could respond. No ties in input, or choose lowest team index or something like that. For now, let's start with no ties in input just to make things simpler. Yes. And what's the max size for the matrix? 100. Okay. So let's just walk through this question and see how it would work in this case. If I were to start with the first team and then check if it has any ones that it is beaten by, well, actually we would be doing the other way around, see if it beats any other teams. Maybe we keep a list of all the teams, so 0, 1, 2, and we are going to start filtering out any ones that are being beaten. So we start with team 0, see if it beats anyone. We see that team 2 is beaten by team 0, so we remove team 2. Then we check team 1 and we see that it beats team 0 and team 2. So we remove team 0 and we're only left with one team at that point. That might be one way this works, kind of a filtering process where we, and by remove, I don't actually mean remove from a list. I'd probably keep a list of Booleans that track whether they've been thrown out. That way, when we go through the for loop, we don't have to worry about like reducing the length of the list and then running out of list at the end of the for loop. Could you break this? Would this work for the first one, for example? Team 0 and 1, we get, let me just reform this so we can see it. So 0 beats 1, we remove 1, and therefore outputs team 0. I wonder if we can break this. I don't want to go too far down this line. I might ask the interviewer at this point, like, that's kind of my rough idea. Do you want me to start sketching it out, or do you want me to consider any others? Let's just pretend the interviewer suggests I think about other options at this point. So let me just say, think about algorithm ideas. Filter out, iterate over list teams, filter out teams it beats, false out teams it beats, go until only one team left. A question here is how do we check if there's only one team left? So this would be O of n times n, I think. So no matter what we do, we're going to have to check every, so here n is the number of teams. I think no matter what we do, we're going to have to check every index in this table to check if a team is valid. I mean, there are some cases where you might automatically rule out everything else, so it'll be smaller, but in the worst case, you might have all matches, or like all ties except for one team at the end. So I think O of n squared is unfortunately the best you can do here. I'm interested to see if there's a table that could optimize that. Like one example is you reformat the table into a hash map of just where the ones exist, so a sparse matrix kind of. But generating that matrix, I think you still have to iterate over all the values anyway, so it doesn't save anything at this point. If it was passed in that way, that might save you quite a lot of time, because then you're only iterating over all the wins rather than all of the wins and losses, and that might be, for a very sparse matrix, a huge time save. Let's see, is there any other ways we could do this? Could we iterate over columns? That way we're checking for each team, which team beats it. So iterate over rows, iterate, is this the same thing or different? Let's find out. False it out if beaten by another team. That actually has some merit to it, because we don't have to check if another team, we don't have to like keep a false matrix per se. We just kind of keep iterating vertically. So let's look at this example here. We started team 0. We check if it's beaten by anything, and we see that just trying to make this a little easier for me to read. We see that for team 0, it's beaten by team 1, so we throw it out. We check for team 1 that is not beaten by anything. We check for team 2 is beaten by 2 teams, so we throw it out. Is there ever a case where a team is beaten by another team? So let's create this transitive property idea. So I actually want to build a table for once now, because I'm interested to see how a transitive team might work. So we have team 1, team 0, team 1, team 2. And team 0, team 1, team 2. And we want to, can we shorten this? Yeah, there we go. And we know that by definition, we're not allowed to beat ourselves. Let's say team 0 beats team 1, but not team 2. And we say team 1 beats team 2, but not team 0. And team 2 beats neither. So right here, we have team 0 beats team 1, and we have team 1 beats T2. And we know that team 0 is beating team 2 by transitive. Does that matter? We already know the winner is team 0 if we remove any teams that beat it. What happens if there's no wins? Can we have an empty matrix? And assuming the answer is no, because then it would be all tied. This goes back to the tie question right here. So assume no ties for now. So let's just assume there's always going to be at least one win. And if not, we just have to count the number of teams that aren't beaten by any other. So let's try that. So I actually kind of like Algo 2. It's a little bit easier to implement. I think you don't have to do anything except iterate over all the rows for that team and only false out that one. A question I might have is, if you have no one beating you, are you automatically the winner? Again, if there's no ties, I guess the answer is yes. Yeah, and by definition, the winner of a tournament is only if there's no team that is stronger than it. So it has to be unbeaten. So simplifying this question, we're essentially looking for an unbeaten team. So if this was a numpy array, you could just sum across the column, like vertically, and check for 0 value, or actually do an all vertically. So there's like a numpy. I'm not going to do this. I assume the interviewer is not going to allow, but you could do numpy all of like a np.array of the grid across the axis 0, 1, I think vertically, and np.argmin, find the one that has no wins. And so you could just return that, and that would be the unbeaten team via algorithm 2. Let's assume we're not allowed to use this because the intent of this problem is to solve it using the standard library and iteratively. So let's say, let me ask the interviewer, okay, so these are 2 of the algorithms. I might be able to think about some others, but shall I go ahead with this one? What I'm seeing here is that we're going to be doing an O of n squared op, because we'd have to check every single value along the rows and columns once. And in terms of storage space, it's actually going to be O of 1, because we don't need to store anything. We're just waiting until we have nobody beating you. And then we just return that directly. If they say, sounds good, let's start with that. We can always modify it later. Let's have a look at how we do that. So I want to iterate over the rows. Iterate over the columns, i.e. check teams beating you. And then for each of them, I want to iterate over rows, check matches if you're beaten. If so, continue, because this is not one, because not winner. All right, so let's iterate. Let's implement that, and otherwise, else, let's return winner. All right, for j in range length of grid, let's just do it with a index, and then for I in range length of grid, we are assuming here, legal grid length of grid equals length of grid 1, and we know it's not a 0 grid. And then if actually, let's see, if grid of ij equals 1, continue, or I actually kind of like the idea of doing something like, so there's in Python an any function which checks if there's any values in a list that are true. And is it all right for me to use that? Let's say if it was allowed, what I would want to do is take grid of all of the values, j. I think you're allowed to do that. So let's see. Sorry, that's a numpy. I was thinking about length of grid. And let's, just to make life easier, I'm going to create a variable for the length of that grid. That way we don't have to keep repeating this one. So if any, that means beaten, continue. And then otherwise, return j, the winner. So that's one way we could do it. And then here we return none if actually we could do that instead of having this if not at the front. We should expect to never reach this. Reach for a valid grid without ties. Or first winner. So this actually will end up, if there is ties, it'll return the first one anyway. If we're not allowed to use any grid, we have to do a for loop. Beaten equals false, and then for I in range n. So let's see, we're about 20 minutes in. I'm just starting to do some minor optimizations here as I'm talking it out. I'm assuming the interviewer, I've asked them about any. They say, oh, do you mind implementing that as a for loop? Let's see, grid of ij if equals true if grid of I tray. I think that's one way to do it, but just to be less. And then finally, and you don't have to continue at that point. And then if beaten, if not beaten, return the winner. So that's one way to do it without using anything special. We're iterating over all the rows and all the columns. So O of n, we're storing nothing except for, we're storing two constant values essentially. And okay, let's talk our way through this. Let's see if there's any errors. Checking for any edge cases. Some of the ones we talked about is the empty matrix. We have a check for that. Matrix as large is okay. Not using numpy. And we have transitive property. We have legal matrices. Maybe at this point, the interviewer asked me if I want to make it a little bit harder, but I'll go to that another time. Let's see. Right now, what I'm doing is I'm trying to look for any mistakes I may have made or any optimizations that would simplify this a bit. So let's see. I don't think we need this anymore because if the length of the grid is empty or 0, we're returning none at the end. So I'm going to get rid of that. Yeah. Just putting this. And we could create comments out of this. This is not strictly necessary. Could we have a case where we have a circular wins? Again, because we talked about legal, let's check. I think they said that there'll always be, they didn't say that there wouldn't be a circular dependency, but at that point we don't have a clear winner, so the answer isn't legal. So I think what would happen there is that we would not ever have a case where values beaten. So as much as I like this, I'm going to assume the interviewers, like after seeing this, they're happy with me not using that. So I'm going to get rid of it. So let me clean this up over here. Let's make this all a little bit smaller. There, just so we can see stuff. That way we don't need to have a beaten. And this becomes a little bit smaller. There are some tricks you could do to kind of one-liner all this, but I don't know if there's, unless the interviewer is interested in that, I could ask the interviewer, like, would you like me to try to make this a one-liner, any tricks along those lines? And more likely than not, they'll say no, because that's just being clever for no good reason. It also impacts readability and making the code easier to modify. So let's leave it at this. I think we have a O of n time, O of n squared time, and O of 1 space. I guess now that I have a working brute-ish solution, is there any reason not to, is there any way we can make this faster? I mean, technically we're iterating until we hit the first loss vertically, but that still means O of n squared, because worst case there could only be a 1 at like the second last value for a very large array of 100 by 100. So I don't think we'd ever get a case. We could always get a case that would have a worst case time complexity of n squared, and summation, all these other things essentially end up iterating regardless. So I think we're at kind of the best we can do here. I'll be interested to see if I'm wrong about that. What else is there? I guess the interviewer could ask me some more questions or complicate it a little bit. Maybe they could say, okay, we do have ties. Could you make one that chooses the lowest team index? And I'd say, well, great. We are already doing that because we're returning the first winner. Alternatively, we could keep a list of, if we wanted to return all the top unbeaten teams, we could build a list. And let me just pretend right here. Exam third pass, all winning teams, tied winning teams. So here, for example, you keep winners, and then winners.append j, and then you just return winners. And that way, for an empty grid, we can return no winners, and for multiple winners, we return all of them, and it'll be in order. We could even return the last one, whatever a person wants. What about a case where we have no clear winners, but every team loses to at least one other team, but the team that loses the least? That's not the definition here. That's a new problem. That could be interesting. I think the way I would approach that one is I would just sum up all the losses on the column. I think the key point here to learn is thinking, I didn't even realize, but thinking along columns, basically your losses, is a really clean way to keep track of how you are doing without having to build up an array the other way if you're thinking about teams you beat. So you could count up all the wins. So let's just say, for example, if we need to have another, well, let's see if I can create that over here. So let's say team 1, team 2, and team 3, and team 1 beat team 2, team 0 beat team 1, team 1 beat team 2, and team 3 beat team 2 also. And that's it. So now we have two teams, team 0 and team 3, that are both unbeaten. This would return all the tied winning teams. What if we have team 0 beats team 1 and team 2? Yeah, there we go. So here we now have two teams that are unbeaten, but team 0 beat more teams than the first team. If multiple winners return one with higher win count, basically is what we're asking here, like tiebreaker, i.e. tie. Well, yeah. The way I could approach this is a two-pass. One way to approach this is a two-pass. You count all the verticals and see all the unbeaten teams. And then for those teams, you count all the rows for those teams and see which one has the highest value. And then you return that. That would be how I'd approach that. Interviewer at this point might ask for the actual code, but more likely than not, we're just kind of exploring different solutions. So I'd say filter to unbeaten teams or teams with lowest losses, and then second pass filter sort by win count for those teams. So that's one way to approach that. If every team has a loss, yeah. Okay. I think I've exhausted some of the possibilities for this one. So we're reaching 30 minutes. Let's pretend the interview has kind of moved on at this point. We asked behavioral and so on. Hope this was helpful to you guys, and cheers. All right, coming back, realize I made a couple of errors, and I need to check this on Leetcode. So first I need to go to 0, and I realize that this any format, first of all, the way list indices works, it doesn't seem to actually go, and now that you separated, you can actually do it this way. But I seem to be getting errors with, let's do this again. So when I tried this one right here, and the grid's the same, but the rest is not. So step 1 was to realize this needed to be a 0 index, and actually you can do it this way, but also you can't use that not without numpy. So here's what I'd been thinking about doing, but this is still numpy form. We're getting every row, and then it's just indexing one of them, which is the wrong. It gets a row. It doesn't actually get the column like I wanted. So I'm going to get rid of that, and error incorrect understanding of 2D error list of list manipulation. So I think the interviewer would probably start asking me questions about this at this point, and I'd realize that I was misunderstanding this. And thankfully, I think this should work where I'm just doing the iteration directly. So here's a point for why you should think about iteration. So let's keep that over there. And let's clean. Oops, sorry, I didn't mean to run that. And then here, oh, sorry, it needs to be capitalized also. I ran the code too many times. I'm pretty sure this should work, but let's try this now. Let's have a look. Oh. Not a good showing for me. Well, that's all right. It's still pretty rusty with doing Leetcode questions, but it's nice to kind of get back into it. And you know what? Being rusty, it's allowed, and you just need to get used to it. And if you keep doing practicing, it shouldn't be too bad. He says as he keeps making errors. All right, let's think our way through this before I run it one more time. Can I see any other errors? Iterating over the lists. I have J, and I'm hopeful at this point that this should run. Let's find out. Okay, seems to pass for both of these. Let's see if we have misunderstood anything else. All right, that seems all right. Okay, cool. I wouldn't say this is the fastest system. If you can use a standard library that allows you to deal with arrays of integers more efficiently, like numpy, especially 2D arrays, you can use basically C code in the back end. That's a lot faster. A lot of optimizations there. For loops in Python will eventually get quite slow when you're iterating over large arrays. So, but that's usually not the intent for this. For these kind of tech interviews, is mostly to understand the logic. And thankfully, usually it's not about the syntax either. These syntax errors, I think as an interviewer, I would start asking myself about them. I would ask the candidate and be like, all right, I notice you're using a grid of I comma j. Is that how lists of lists work? Then me as a candidate would say, I'm not entirely sure. I think I'm thinking about numpy arrays, and I was assuming that it was the same for Python arrays, but I think on further introspection, it's different. And maybe I would make some updates. I might still have errors. The interviewer might do a little bit of back and forth with me if they're trying to understand what's going on there, because not understanding the syntax is not as important as long as you can explain the logic of what you're trying to do. And yeah, anyway, so hopefully that was fun for you guys, and have a good day. Also, just for fun, I realized, let's talk a little bit about some optimizations here. So we've realized that this any doesn't work with list iteration. Slicing a list doesn't work like the way I'd like it here. So let me just talk through what I meant by that. So if we have a list of lists and we try to do a grid of all the rows, but a certain column, the intent is all rows, certain column. But what actually happens is grid of this just becomes grid, and then we get grid of, so what happens here is grid of this and this becomes grid of that, and that's just a certain row. And that's where we were getting our main error. We can do some little quick stuff here to make it a little bit easier. So sorry, to get us closer to the numpy type approach of what I was intending here. So a way you could do that is you could do some sort of for loop within. So let's say grid of j for I in range n, and that way it gets you all of the columns, and then you could do an any on top of that, for example. And in fact, you can get rid of generating a list and turn it into an iterator, which is relatively fast. And so I think from there we could get what we intended here. So let's have a look at whether that works or not, and that might give us a slightly cleaner looking code. Actually, I just want to change that bit right there. Otherwise we return. So here's what I'm thinking. We're iterating over the range of n, and we're getting all the rows, but a specific column j, and then we're doing an any over that, which means if any team beat it. So let's have a look at if that runs now. Yeah, that looks good. And let's do a submit there. Yeah, and that's just fine. And speed's not really important for this kind of stuff, because this slowdowns and speedups have all to do with interpreter Python and the backend system that's running it, and very little to do with the algorithmic efficiency at this scale. Okay, that feels a little bit better. I hope you guys enjoyed that. Here, I think during an interview I'd get this. We're still, sorry, I stopped the timer, but we're within a couple minutes of the last video, so hope that helps.